Okay, so we are discussing one example to walk over the shortest path. So to begin with, so suppose this is our start node. Let's also mark the, okay. Okay, so now to begin with, all the distance estimates, the D values is what I'm writing inside the node. They are all set to infinity. And the parent is also set to null pointer. And the distance estimate from S with respect to S is clearly 0. So that is what is set. Okay. So now what is the first step here? So we have added everything into the priority queue and we are extracting the minimum value node. So what is the minimum value node that it's going to extract here? Which one has the minimum value? You tell me. So when we are doing extract min on the queue here, which node will come out? Which has the minimum value? You can see here, right? The D value 0, infinity, infinity. So clearly this S node is going to come out, right? So S dot D, which is the 0 value. So that is the minimum. So now with respect to this, the two edges to consider are this and this. So it is going to now relax. So it's going to see whether the D value of this one, which is infinity. Oh, I have not assigned some value here. Hold on. So this is 3 and this is 2, let's say. So now I want to see with respect to this node, which is actually giving me a better relaxation. So the step is that I want to see with respect to this V. So you see this is U and this is V, correct? So with respect to this edge, I want to see can we improve on the value of the D of V, which is infinity. So clearly I can improve on this. So this becomes 10, right? Because it is 0 plus 10 is less than infinity. This becomes what? 0 plus 5 is less than infinity. So this becomes 5. Is that clear?
Can I ask why doesn't it consider like 5 plus 3 is 8 and still less than 10?
5 plus 3, you say?
Yeah.
It has still not updated yet, right? It is infinity to begin with.
Ah, I see.
So the first update it makes is just with respect to whatever the D value is, which is infinity. So it becomes 10 and this becomes 5. Now in the next step of relaxation, so now it has got essentially what is the minimum key value? So it has got so this is extracted out, right? So now you have these two nodes. So I think I need to label these, otherwise we will not know which node we are processing. So suppose this is 0, this is node number, let's say, just for identification purpose, 0, 1, 2, 3, 4. Okay. So the next, I'm going to extract which node, you tell me, because it has got 5 and 10, right? So it's going to pick this second node, right? So node 2 would be, so first node 0 was picked, right? Next node 2 will be picked. And then we are trying to see with respect to, so now this becomes our U and we are trying to see what other edges are connected, right? So we have the connectivity going to node number 3, node number 4, and node number 1, right? So that the edges to relax would be, so essentially the edge that is going from 2 to 1, then 2 to 3, and 2 to 4. Okay, so now it is going to see with respect to 2 to 1, can I improve on the D value of this? So now it has got some more value. So as you pointed out, so this has got 5. So it's going to see 5 plus 3, 8, which is less than 10. So I can improve this. So this now becomes 8. And then with respect to 2 to 3, this clearly will become 2 plus 9, 11. So this becomes 11. I better change the color, otherwise it's very confusing. So this becomes 8. This becomes 8. And this becomes 11, right? So 2 plus 9, 11. This becomes 5 plus 2, 7. Is that clear how it is progressing?
Did you mean like 5 plus 9 equals 14 or 2 plus 9 equals
Oh,
11?
sorry. Why did I say? Hold on. This is 2, right? Why was this 2?
That's node number 2.
Oh, I'm so sorry. This is 5, sorry. 5 plus 7, 14. Correct. 5 plus 9, 14. Thank you. That is correct. So the new D value will become updated to say 8, 5, 14. That's correct. So then with that, now you can see which is the minimum one to be picked next from the queue. So now the node 2 has been processed. So node 2 has been already removed out of the picture. Okay. And this is where the greediness is coming in, that you are already kind of processed. So therefore you're just going to the next possibilities. So next series, the set of nodes to be picked would be out of whatever has the least value. So what would be the node to pick? You tell me.
So it'd be the 4th node.
Exactly, because it is the 7th. Yeah, exactly. So 4th node would be picked. So node 4 would be the next one to go. And then the same process gets applied. So you can go on and then until it has gone through each and every node. So you can see that until the queue is empty, because extract min is also taking it out of the queue. So at the end, you will have at the end, what you will see is that every node has been annotated with the most tight, or you can say tightest bound of the shortest path, along with the parent pointer, because you're also updating the parent pointer at every step, right? So you have got so this step is giving you the shortest path. And this is going to give you the overall weight, or the overall length of the shortest path found so far. So I hope like this is clear.
Yeah, this makes sense. So then like we keep on extracting the minimum, right? But we're doing that while the queue's not empty. So we end up, checking, I guess, updating every node like in order.
Yeah, that's why I cautioned here. That's why I cautioned here. So this is updating the D value. So the key is changing. This is a very unique thing. Typically the keys don't change, but here key is changing. So that's why cautioning you. So this is where your implementation will come through in this lab. Okay. So let me